Simple pendulum energy. A mass of 0.062 kilograms oscillates on a simple pendulum with a length of 1.6 meters, and that's this. This is the length of the pendulum, and it's also right here before it swings up, and it reaches a maximum height h of 0.08 meters when it is in simple harmonic motion. What is the maximum gravitational potential energy? What is the maximum kinetic energy? What is the total energy of the system? What is the maximum speed of the mass? And what is the period of oscillations? The maximum gravitational potential energy is when the ball is at the maximum height, h. So GPE is mgh. Substitute in our mass, the value for the gravitational acceleration, and the height, and we get 0.0486 joules. What is the maximum kinetic energy? We're going to use conservation of energy, and we can do that because here's our work energy equation. There's no work being performed on this pendulum as it swings, so initial energy is final. At the bottom there's no GPE, right? We're taking this as our GPE equals 0 location, so it's all kinetic energy. And at the top, the pendulum swings until its velocity stops, and then what happens? It swings back the other way. So the velocity is 0 at the top, so there's no kinetic energy. Therefore, the kinetic energy at the bottom is equal to the GPE at the top, which we already found out, 0.0486 joules. Energy is conserved, no energy is transferred out of the system as it swings from the lowest point to the highest point. What is the total energy of the system? Well, at the top, all the energy is in GPE, and at the bottom, all of it's in KE. So the maximum energy is either the kinetic energy at the bottom or the gravitational potential energy at the top. So the total energy is the same. It's 0.0486 joules. What is the maximum speed of the mass? Well, let's look at the bottom when the only energy we have is kinetic. Kinetic energy is 1/2 mv squared. So where you have the maximum kinetic energy, that's also where you have the maximum speed. The mass is traveling fastest at the bottom, over here, and slowest at the top, where it's equal to 0. So we solve the kinetic energy equation for velocity, multiply both sides by 2 over m, and on the right side, that will cancel out the 2, the m cancels out this m, and we're left with v squared, and on the right side, we have 2 over m times ke. We then take the square root for the velocity, substitute in our value for kinetic energy, and there's the mass, and we get a velocity. The maximum speed is 1.25 meters per second. What is the period of the oscillations? For a simple pendulum, the equation is period is 2 pi times the square root of the length, this here, divided by the gravitational acceleration. It does not depend on the mass. So we substitute in L, here's G, and we get a period of 2.54 seconds. And make sure you take the square root here after you divide L by G.